maintenance, okay? So, we are only going to be covering two different kinds of transformations today. Translations, which are slides, you guys know slides, and reflections, which you know is flips, okay? So, your homework tonight is just 1, 2, and 3 on page 74. Okay, now, here's the thing. Keep it because you're going to be doing 4 through 9 later. We're going to do rotations on Thursday, okay? So, make sure you keep up with it but you only have to do 1 through 3 tonight as homework, okay? Alright, so, turning your books to page 506. Green books, page 506. Okay, now, we're going to be doing, like I said, transformations for the next couple of days. Transformations are just taking a geometric figure and basically moving it in space in different ways. The word transformation is the general term for moving a geometric figure. Okay? Page 506. Now, a translation is what you guys know as a slide. Now, you're going to need to know the word translation. You're going to have to start knowing the other terms for the math, for what we're doing in math. Okay? So, translation is a slide. That means if I take this triangle here, and I move it around in the coordinate plane, it doesn't change its look, it doesn't change the way it's facing, it doesn't get flipped, it doesn't get rotated, nothing. All it's doing is you're actually taking it and moving it around in the coordinate plane. Okay? So, when we look at a slide, all we're looking at is taking each vertex and moving it the same direction, the same distance for every point in that geometric figure. Okay? But we only move the vertexes because then we can just connect the dots. Okay? So, up here we have this triangle ABC, where the point A is negative 2, 2, point B is negative 5, 2, and point C is negative 5, 6. Now I gave you the grid paper there, the coordinate plane paper there, so that you can take notes if you want to. It's easier with that than freehanded. Okay? Alright? So, if we want to take this triangle, and let's say that I don't want to go that far. This is another one we're doing. Let's say I want to take that triangle, and I want to move that triangle, let's say, 6 units to the right, and 3 units down. Okay? We're going to move that thing 6 units right, 3 units down. If you've got a drawing up there, it is as simple as taking each vertex and moving that many spaces, the directions it tells you. Okay? So I'm going to use a different color marker here so that we can tell the difference between one triangle and the other. Okay? So, I'm going to take point C and I'm going to move point C 6 units to the right. So I'm going to go 1, 2, 3, 4, 5, 6, and then move 3 units down. 1, 2, 3. There's where point C ends up. Okay, that's 6 units right, 3 units down. Now, in math, we don't want to just repeat the same points that we've said previously. Because, especially since you guys have, like, pencils and stuff, you don't have different colored pencils. Okay? It makes it easier, but if you don't have them, you don't have them. So what we do in math is that we call that C prime. And all that is it's a little mark after the C that looks kind of like C to the first power or C with an apostrophe behind it. That's called C prime. And that just tells you that that is different from your original triangle. Okay? Now, same thing, we're going to move B 6 units to the right. 1, 2, 3, 4, 5, 6, and 3 units down. 1, 2, 3. And we land right there for B. And this is B prime. It is the The second triangle that is not the original, okay? Okay, we feel good? Done. 3. We're going to move all of them 6 right, 3 down, okay? And now A is moving 6 right, 1, 2, 3, 4, 5, 6, and 3 down. 1, 2, 3. All right, now we connect the dots. And that is A prime. And we have the same size triangle, just moved down over 6, to the right 6, down 3. It looks the exact same, it's the same size, it's just being slid down that direction. Okay? Make sense? Okay? Now, it's relatively easy when you guys have drawings up there and you physically actually move it yourself. You know, all right, I'm going to take this point, I'm going to move it 6 right, and then I'm going to move it 3 down and put my point right there where I land, right? Okay, well, we can also do it on paper. Okay, and what I mean by that is, all right, let's see what points we landed at here. C prime ended up at 1, 1, 2, 3, 1, 3. Okay? B prime ended up at 1, negative 1. A prime ended up at 4, negative 1. Okay? So, let me go ahead and write those up here. 4, negative 1. B prime was at 1, negative 1. And C prime was at 1, 3. Okay, now, the movement right 6, did that affect our X or did that affect our Y? If we moved right 6, did that affect our X or our Y? That affected our X, right? Because we moved along the X axis. Okay? Well, in our coordinate points, we have an X coordinate and we have a Y coordinate. Well, I'm going to go ahead and I'm going to write down that 6 as not an X coordinate, but the movement of my X coordinate, because it affected my X, right? Okay, well, my 3 that I went down affected my X or my Y. It affected my Y, because I moved up and down my Y axis, right? Okay, now, just like the coordinate plane, anytime you go right or up, that is a positive movement. Anytime you go left or down, that is a negative movement. Okay, so we went 6 to the right, so that was a positive 6. We went 3 down, so that is a negative 3. If we take the movement that we took each vertice and moved it, if we will add that to the original triangle, each point will get where we landed later. In other words, if we take the X coordinate of A, negative 2, and we add the positive 6 that we went, we end up with positive 4. That's our X coordinate. If we take the Y of our A and add the Y of our movement, 2 plus negative 3 gives us negative 1. So we went from negative 2, 2 to 4, negative 1
Teacher, please release the lunch lab students at this time.
By moving 6 right, 3 left. Okay? Same thing with B. We moved it the same. We moved C the same. But they all need to move the same direction, the same distance, right? 5 plus 6, or negative 5 plus 6 is positive 1. 2 plus a negative 3 is a negative 1. Negative 5 plus 6 is a positive 1. 6 plus a negative 3 is a positive 3. We don't even need the chart or the graph in order to know, here are your points or your vertex of your triangle. If you're going to move 6 units to the right and 3 units down, if you will write it as a coordinate point and you add them together, you'll find out what it is without even having to draw it.
Would there be like one more coordinate?
Do what?
Like instead of like a triangle, like there was another.
We can do a quadrilateral, and it'd be the same thing. If I added another point right here, it would move 6 that way, 3 that way. Whatever the point started at, we would add the 6 to its x, we would add the -3 to its y, and we would find out exactly where it landed. Okay? Does that make sense? Yes, no, maybe so?
Yes.
Maybe.
Yes? Okay. All right, let's say, all right, are you sure?
Yes.
We good? All right, because I'm going to move on to reflections real fast. Because we don't have a whole lot of time left. Okay? Do what? I know. That's why we got to go ahead and get to it. But these, you're going to see more of these probably on chunk test and benchmark than you will, like we're going to do rotations. Did it go off?
No, I'm trying to make sure it stays on.
Okay. Because you're going to see more of these and reflections than you will rotations on anything else. Benchmark, chunk test, all that stuff. Okay? All right, now, reflections are a little bit easier, actually. All right? Let's say we're going to take this same triangle, and we want to reflect it over the x-axis. All right?
Wait.
If you look on your sheet here, under the notes, it says, when reflecting over the x-axis, use the same x-coordinates and multiply the y-coordinates by -1. If we want to reflect this over the x-axis, this is the x-axis, right? This is our mirror. The x-axis is our mirror. So when we see that mirror, the reflection is going to be down here. We reflect it over the x-axis. So, if we want to reflect this over the x-axis, don't we need to go out the same direction on our x-axis?
Yes.
All our x's need to be the same because they need to be here so they can end up there, right? So, all of our x's stay the same. -2, -5, -5. Well, we want the y's to be the exact opposite. They need to be on the other side of the y-axis, but they need to be the exact same distance from the x-axis that one is. Okay? So multiply each y coordinate by -1. -1 times 2 is?
-2.
-1 times 2 is?
-2.
-1 times 6 is?
-6.
So this should be the coordinates of your reflected triangle. -2, -2.
Wait, so it's always going to be -1?
Yes, always -1. Okay? B prime is -5, -2, and C prime is -5, -6. Okay, this is A prime, this is B prime, and C prime. And it's the exact same except for it's reflected over the x-axis. Yes?
So you just making that from the middle column?
What, in the middle column? Well, I wouldn't put anything in the middle column because we were adding it a while ago. I would do this. Y coordinate times -1. Okay? X stays the same, Y coordinate, you have to multiply by -1. Is that your question?
Yeah, because I thought you had said 6 times -2. I heard wrong.
No, -1 the whole time.
Okay.
Okay? Make sense?
Yep.
If we want to reflect over the y-axis, okay, let me get a different color for that. If we do that, we want all of this to be here, right? So we want our x's to be the exact opposite and our y's to all be the same. So what we'll do with that, and let's do this with A double prime, B double prime, C double prime. Our x's need to be multiplied by -1. So -2 times -1 is what? And our y's stay the same. Okay? -5 times -1 is? Our y stays the same. And then C is 5, 6. Hold on. So we end up with 2, 2, 5, 2, and 5, 6. On your homework, make sure you pay attention to what axis it tells you to reflect around. think the first one's Y and the second two are X, or vice versa. Okay? See y'all later. 1 through 3 only. Oh, hold up. Put all your green books on your desk, please. All your green books on your desk. Do that, you get out.